So we want to now discuss how to solve exponential equations. You saw a little bit of it in the previous section when we talked about exponential growth and decay, because we had to solve these a couple times for the exponent. But basically what you're going to do is you're going to use a common base to solve it. And then if you can't use a common base, we'll talk about that after we talk about logarithms, because that's the other method. But the method that we're going to use, if we can, because it's simpler, is to solve exponential equations converting a common base. So what do we mean by that? Well, what we mean is when you look at 4 and you look at 8, you want to recognize that those are both powers of 2. 4 is 2 squared and 8 is 2 cubed. So that's what we mean by converting them to a common base. Okay? And then it says to set the exponents equal. So what we do is you notice that this is, in one more step, is 2 to the 4x if you just multiply those. And this is 2 to the 3x plus 3 if you multiply the 3 by x plus 1. And so then we drop the bases and we say that means that 4x then has to be 3x plus 3. And if I subtract 3x from both sides, I just go minus 3x and minus 3x, then what I'll end up with is that x is equal to 3. And that's my answer. And as with any equation, you can always go back and check. So we can go back up here and say, is that true? And that means 4 to the 6, right? 2 times 3 would have to equal 8 to the 4th. And if you grab your calculator real quick, I'll just show you on mine. If we go 4 raised to the 6th power, it gives me 4,096. And if I take 8 and raise it to the 4th power, I get 4,096. So because they're the same, I know that I'm right. And it's true of any equation, but that's the steps. You can always go back, I guess what's true of any equation is you can always go back and see if you got the right answer by plugging the number into the original equation. And it should work if you're saying it solves it, all right? So we're just going to go through a few examples of that. So with 8 and 16, we want to look for a common base. The common base is again going to be 2, so it's 2 cubed. And you do have to be careful because the temptation sometimes is to put 4 there because there's a common factor of 4. 4 squared is 16, but 4 to a power doesn't give you 8. All right, so you want to use 2. So we're going to go 2 to the 4 to the x plus 1. So then we're going to multiply. So we're going to get 2 to the 9x minus 6. You're just going to multiply both of these by 3. Okay, and you're going to multiply both of these by 4. So we're going to get is 2 to the 4x plus 4. And then I'm going to set the exponents equal. So that means 9x minus 6 is going to be equal to 4x plus 4. And if I subtract 5x, in other words, I bring the 4x this way, sorry, not 5x, and bring the 6 that way, I'm going to have 9x minus 4x, which is equal to 5x. That's where I was getting the 5x from. And over here, I'm going to have 4 plus 6, and that gives me 10. So if 5x is equal to 10, I can say then that x is 2, and that's my answer. And again, you can go back up and check. I'm not going to this time, but I would encourage you to if you want to. Okay, here's another example. This one, we have to use 27 and 9. We're going to use a common base of 3. So 27 is 3 cubed to the x plus 3. And then I'm going to write 9 as 3 squared, 1 over 3 squared to the 2x minus 5. And then what I'm going to do is I want this to be 3 to a power, not 1 over 3 to a power. So I'm going to change that to make the power negative. So it flips the base. You remember from when we talked about negative exponents. So we're going to get 3 to the minus 2 raised to the 2x minus 5. And that gives me 3 to the 3x plus 9 is equal to 3 to the minus 4x plus 10. Okay, if we just multiply both of those by minus 2. So therefore we drop the exponents. We get 3x plus 9 is minus 4x plus 10. So we bring the minus 4x that way and the 9 this way, and I get 3x plus 4x is equal to 10 minus 9. And that means that I get 7x is equal to 10 minus 9 is 1. So x is 1/7. Now, if we go a little further, you again can do these. This one's a little more complicated, but again, we look for a common base. So we're going to go 2 is the common base between 8, 16, and 32. 8's 2 cubed. 16 is 2 to the 4th. And then 32 is 2 to the 5th. So that gives me 2 to the 3x plus 18 divided by 2 to the 8x minus 4 is equal to 2 to the 15x minus 20. Okay? And this is where this gets a little more interesting, because when you have the common base here, it's a division, so we're actually going to subtract these. So we're going to go 3x minus 8x is minus 5x, and 18 minus 4 is 18 plus 4, so it becomes plus 22, is equal to 2 to the 15x minus 20. And then I set the exponents equal, so minus 5x plus 22 is 15x minus 20. Then I bring the minus 5x that way, bring it over to this side, and I'll bring the minus 20 that way. So I get 22 plus 20 is 15x plus 5x. So that's 42 is equal to 20x. So that means 42 over 20 is x. Okay, and if we divide them both by 2, first, you'll get 10 on the bottom, and 42 divided by 2 becomes 21. Okay, and then you can leave that as 21 over 10, or you can write it as 2.1. All right, so that's the concept. And again, you go back up here and check it to see if it works. And I'm not going to take the time to do that. But if you do, make sure you check it properly, because sometimes if you check it and you do something incorrectly in the checking of it, you plug an x in the wrong place, you can end up thinking you're wrong when you're actually right. So you do need to be careful when you check, but it's pretty easy to do that if you just plug the x's in back up here and see what happens. All right. I'm not going to go through this final example. I think that makes sense, and it's very similar to the one we just did. But the question then becomes, what happens if we can't set the bases equal? Okay, and we'll talk about that with logarithms. So we're going to introduce logarithms next, and then we'll discuss how to solve exponential equations using those logarithms.